Hello and welcome to my midterm project in financial modeling with spreadsheet, spring 2018. My name is Tal Horovits and I'm going to present you my project, which is about the New York City subway system. The reason why I chose this specific topic is because I'm fascinated by the subway system. New York City is one of the most populated cities in the US, and being living in the last 5 years here in the city, I consider myself being an expert about the subway. I can easily know what trains to take in order to get wherever I need. I also know where to stand on the platform in order to exit really fast. But the question that I wanted to research was which station I should avoid, especially when a tourists are attacking the city. So looking at that, I was obviously retrieved my data from the MTA, and here we see the metadata. So specifically my file, the data set that I've been working on was compiled by Frank Donnelly, who's working for Baruch College, but was retrieved from the MTA website. It contains the total annual ridership, the average weekday ridership, and the average weekend ridership from 2017 to 2016. Rideship is actually the swipe of the Metro card at the entrance to the station, which gives us a good indicator about how many people enter the station and use that. So we're going to use that. One of the first things that I noticed working with that this file was good. It was dataset was big, but not huge. I did wanted to try to get some more information about breakdown to hours so I can see the peak times and also to see delays. But when I had those files, they had more than 1,050,000 rows, which is the limitation of Excel. So this is something that I learned during working in Excel. I tried to be smart and use Access and connect the tables like I learned in class, but that ended up with the file with a size of 2 giga. So I passed that. Let's take a look at the data itself. You can see that this is the data that I've been working on, I received. So here we have the complex. Two first letters, as I learned from the metadata, are representing the borough. So you have Brooklyn, BK, and then you have the complex and the trains. I'm going to use mostly the complex because I'm not going to look specifically on trains because as you can see, a complex can have more than one train stops there. For example, in Prospect Park, you have F and G stops. And there we have the location, which helped me to put up a map later on. And then we have the data itself. So for example, let's take a look at that. We have 1,800,000 ride ships. I mean, people who swooped the card in 27, total of 2007. And also I have the average weekend and the average weekdays. Since I don't want to spread around, I only looked on the years between 2014 to 2016. So the first thing that I did was to clean my data just to be able to work with it. I obviously put it in a table. It really useful and helpful to work with tables. Excel know how to identify the table in order to work with the pivot tables and also charts. I did some formulas. As you can see, here is a formula that I created in order to retrieve the name of the borough from the complex ID. And also I separated the trains so I can count them. And pretty easily, the first thing that I did was to use conditional rules and to just paint, as you can see with green, which station were the busiest, I mean, had the largest, the biggest amount of rideship. In 2014 total, of 2015 total, and also the average and weekend and weekdays, which is not surprising. You can easily see right now, I sorted that from the biggest to the smallest. You can see that the busiest station is actually Times Square, which is my hypothesis is because it has the most train stops there. So you have like 1, 2, 3, 7Q, RW, etc. So let's take a look on the sheets that I actually put together. I used pivot tables and tables to create station statistics. You can see here the total distribution of stations. So for example, Bronx has 67 stations, Brooklyn 157, Manhattan 119, and Queens 78, total of 421 stations in New York. Which is kind of surprising because Manhattan has fewer stations than Brooklyn, but has more ride ships, as we're going to see later on. And then we have this pivot table that shows the trains, the number of the trains, and where are the stops that they have and how many stops. So, for example, train number 1 has 3 stops in Bronx and 34 stops in Manhattan. total of 37. From here, I can easily see, for example, the train 5 and 2, and also the F and the R has the biggest number of stops in the city. And here I put a pivot table that shows the top 10 busiest stations in each of the boroughs, which was really easy to see from the table. And it's really nice. I like Excel, working with Excel specifically because of the slicer. It's a great tool. So for example, if I want to focus specifically on Manhattan, I can just click here and it will automatically sort and filter the tables to show just the relevant data of Manhattan. Also, I have the complex here. Let's move forward because we have some great things to show you. The ride chip statistics, as you can see here, also a sheet that I put up with all kind of information that was interesting and helpful to answer my questions. So here you can see the boroughs and the years again. This is a total, but now you can see the distribution of ride chip in percentage. So for example, Manhattan is actually accounting for 55% of the whole ride chip in 2016. This can be presented here in this graph. You can see the years. Even though it's kind of stable between the years, you can still see there is a slightly increase or decrease between the boroughs. What's interesting to see here is between 2014 to 2015, you have an increase in the annual total ride chip, but between 2015 to 2016, you have a decrease. Which is really interesting because if you're looking on the amount of tourists that arrive to the city, for example, it's always increasing, and only 2017 was the highest number, groundbreaking, a record of almost 63 million tourists arriving in 2017. So here you have a summary of the ride chip, and here you have some nice charts showing the change in ride by part of the week and years. So you can see that average Saturday and Sunday had some kind of a decrease between 2015 to 2016, but the average weekday increased, which is, it's interesting for itself because we can dive into it and try to explain that. Let's take a look on the dashboard that I created. So here is a ride chip summary. You have the average weekends, the average weekdays, and the total. And here you can see the distribution between the boroughs. For example, what I like about that if you just choose Manhattan, it automatically filters everything. So what's interesting, as I said before, is you can see that there is a decrease in the average weekends between 2014, 15, and 16, while the weekdays and the total kind of stayed stable and even just increased just a bit. This is interesting, but I'm not going to cover this in this video. If I had more time, I would definitely dive in to see what happened there. This is the change in the ride chip as a percentage. So you can see here also what's interesting here that we can see some station had a increase in 2015, which is the blue line, for example, here, and some station in 2016 had a major decrease. I will say this is because constructions or they closed the station or something like that. But again, this is out of the focus of this specific video, but this is something that I found really interesting. You can see here another peak and here another one, and pretty much here you can see an increase and a great increase. This is in Fulton and Grand Central, which might suggest something about the work labor there and number of people commuting there, maybe number of jobs that change between the years, perhaps. Let's take a look on the train distribution. I like this chart a lot. You can see the train number 1, like according to the trains itself, and you can see the number representing the boroughs, as we saw before in the pivot table. So for example, train number 1, you can see they have 3 stops on Bronx and 34 on Manhattan. Again, you can easily filter that, just choose whatever you want to see. So let's take a look at Manhattan, and from this easily you can see the train number 1 has a lot of stops, and also you can see that the C is leading, etc. And from the overall, you can see the train number 2 and F and R and 5 has the most stop. The last one, which is actually answering my question, is the map, which I really like. And here you can see according to the boroughs, and you can see the top busiest 10 spots in each borough. If I had that on the phone, that would be awesome in a real time. So this is my answer to the question. I hope you enjoyed this video. Thank you very much and goodbye.